Welcome in.
Hey, what's up? All right. So what we're looking at here is a variation of a closed loop system. And what that means is it's charging and driving on the same battery.
Okay.
Um, that's basically we are losing. I'm just gonna burst any bubbles right off the bat. It's spending.
So that was at 12 something.
Yeah, I was at 1252, 12.52 this one.
Oh, good. Let me grab that. Oh, yeah. Down 200s.
Yep. And it took about an hour to do that.
Wow.
Yeah, on itself running, and this is going. That's not that great. I mean, an hour to go 200s is going down pretty noticeably. 575 RPMs.
Welcome in, Real Gizmo Society.
Hey, what's up? How's it going? Um, Now the way that it's happening right now might be because I tried to incorporate this coil into the direct flow of the generator flow. And I don't think that I did very well.
What are you grading yourself on?
How fast it's going down.
Got it. Okay.
I
So
think
you
something's not hooked up right.
so you would want 100th in an hour instead
Yeah.
of two?
Well, I mean, the first time I hooked it up, it was a relay, not a closed loop system, but a relay, and it took like 3 days
Okay.
to do 100. So that's what I'm going off of. But this is a totally different system than the one that I built before, which was a relay. It had two batteries,
Dose.
and they swapped back and forth off the SSG input and output.
They were swingers.
Yeah. So how I manipulate how much this says, this is the AC voltage coming off of that coil. And it is hooked up to this cap bank over here. So the AC goes into here and it comes out DC. And this is where I have everything screwed up because I got the cap bank output connected here so that I could just have this output connected to the battery and have it be one connection. It's either working or it's not working, but that's what the intent was. And well, I don't know. It might be working.
You do got a lot of connections up in here.
See, because um, the output's going into the cap bank over here, and I'm thinking that it's forcing. Because what thing I did was I hooked it parallel to the battery, right? So that it would sync with the battery.
Mm-hmm.
The voltages would sync, and the capacitance hopefully would sync as well. But I think the battery has a little bit more capacitance than the cap bank did. Anyway, I think it's basically synced up. And there's the thing, man. I think. Here, let's try this. I'm gonna unhook this.
Hey, group. Yeah, we're in the year 1997.
Oh. Yeah. Okay. So we're gonna just touch. Oh, we got it.
See if I can get that on the meter.
That's so weird. Oh, 1251. Yeah, they're synced up. Okay. I was reading the wrong one. Huh. Okay, so Doesn't matter which one I clip it to, they're gonna say the same thing. We're good. All right.
We are good. We are golden. Welcome in, everybody. Thank you for dropping by.
So why am I monitoring the AC voltage coming off the coil? And thank you for coming by. I appreciate it. One reason is that I wanted to get a different reading. Because you hook it up anywhere on this thing and it's going to say 12.50.
Right.
It's going to be a straight line, but you know, you hook the oscilloscope up to this coil and you get something else. Okay, you get like a little square wave here. It's just about a 60, 70 peak to peak, something like that.
Let's see if I can get a better zoom. That's a little better. Sorry about that, guys. That's sweet.
There. That's what we're working with. So we got a square wave and then we got our little pulse motor wave. A little, I don't know what you even call that. What's an M wave?
Yeah.
Half of a sine wave or a little sine wave in there? Don't know. It is, for the most part, a square wave. Coming off of this coil, but it's because it's already connected on the other end to all this stuff. So it does have a load on it, which would suggest square wave. You know, cutting the top off of the sine wave and using that energy to run something.
Thank you for the like.
And it's all rectified. All the energy is rectified, both in this cat bank and the circuit right here. It has the diodes, so it's DC rectified.
And the lights are on, so it is going.
Awesome.
Hey, everybody, welcome in. Drop a like, subscribe. Let us know if you have any comments.
Hello, hello. What up, what up? Okay, now to adjust what this is going to do, we can just move the coil in and out. So I'm going to push it in. Just like right there. It's going to slow down a tremendous amount. Let's take a look at that. $493 now. But it might be, you know, what we need to send it over the edge, generating more electricity with this coil. Of course, my ultimate hypothesis is that in the closed loop system, this one in particular, we're going to end up spending. Now we have a potentiometer here. It's a 25 watt, 1000 ohm potentiometer. Let's look at where we are right now. Okay, we're close to being without any resistance, I would imagine. So like here would be 150. So we can add a little resistance, I think.
Thank you for the like.
All right, look, we got an extra hump on our oscilloscope.
By messing with the potentiometer.
Yeah.
Nice.
in our, well, let's back it out a little bit. Wow, yeah, that's really different. It's really different. Cool. And that's from that, yeah, that's great. All right, but let's check the speed one more time before we, yep, we're down to 395. It's fluxing though. So let's go the other way.
It's tighter.
All right, so we're virtually like maybe 50 ohms right here.
50 ohm, maybe. Thank you for the like.
Looks like we're going up. We're at like 445. Can't really tell whether it's going up or down right now. It might be a good place to put it down. Wait just a minute, see which way it's going.
See which way it's going.
It's kind of like at an equilibrium right now. It's not going up or down.
Equilibrium.
And its RPM it's like right at around 450. So I don't know. I guess we'll add a little bit more resistance.
420 RPMs.
That's going down. Well, I think with that coil in there, the resistance, it doesn't like it very much. Like, to keep going at a significant pace.
Oh, it's being a stickler.
Yeah, the lens effect is a real stickler. 410, 412, 418,
420.
408,
Ah.
411, 405. This thing is all over the freaking place, man. It's not good.
Thank you for the like.
Thank you. It's awesome. All right. So, if speed is truly what you need, let's back this out. We'll leave it so it gets a reading here. But taking it out is going to increase the speed significantly.
There's a change. Oh my goodness, it looks like a mountain.
Yeah. And the faster it goes here, the more of a reading we're going to get here. Because, you know, the field expands outward, or in the direction the magnet is facing, the more it spins. And this is axial flux, so it's facing down. Yeah, and it's working pretty good.
It's working pretty good.
You got that. See, that angle right there is actually pretty freaking good for a neodymium magnet. The angle and the distance of the coil away from the rotor. So that's like actually pretty optimal for energy generation right there. instead of directly underneath it, which is going to lens it to death.
Optimal. What's up, Yanni?
What's up, Yanni? Whew. That is an awesome wave there. Square wave, sine wave mix. Closed loop system, ladies and gentlemen. Let me describe the path. Okay, we got battery to SSG. Runs the 20 gauge coil right here, which is 1500 turns, with an external trigger. Let me see here. The output is connected to the cap bank. And this coil right here is connected to this cap bank. And then this cap bank is connected to the ass end of this cap bank.
Okay, all right.
So virtually what you have is like a continuance, because the end of this cap bank is also connected to the battery that you started with. So it will go from the cap bank through this connection to the battery, and whatever comes from this coil will go through this cap bank through this connection to the battery as well.
That's insane.
Which will prolong how long it takes to decrease in value, the voltage.
So, truth hurts. We started at 12.52. It is now down to 12.5, and that was about 3 hours ago. It was 12.52.
Yeah, it was at 12.52 for a while.
So that would be spending energy. Thank you, Truth Hurts. Thank you for the comment.
Absolutely. That's what I said when we started. That I'm sorry to burst anybody's bubble, but this is spending. And I knew that was going to happen from the start, but I'm just interested in how long this will run itself, basically.
Right.
And it's not running itself, from the energy generated from the coils, because that'll never happen. But it is running on the energy from this battery, which is recycling itself and losing, I'd say, 100 every 35 to 40 minutes.
Okay.
Wait a minute, when did we start the stream?
We're 17 minutes into the stream, and I got here after 8.
Okay, so it might have been 12:52. It might be going a lot faster than I think it is, which is okay.
Okay. I got it.
It's okay. We know that it's spending. It's just the rate that it's spending is what we have to. I've done a lot of potentiometer twisting and all that. We gotta give it a minute to settle.
We got to do a live where it's just focused on, and then you could be sleeping over here, but then we can calculate the time and how quick training. I'm just playing.
Yeah, no, that would be awesome. I don't know about the viewage.
Yeah.
We'll see.
It's like, what are we looking at? We're looking at numbers on a meter. We're doing just label it experiment.
Yeah. Experiment. Okay. Now we're out of context.
And then put some binaural beats on it.
That's actually kind of making it right where it needs to be, man. This is an experiment. We're still at 12.50. It's been there for a minute.
Thank you for the like.
And here's the question, really. Is a bifilar coil going to run this better than the setup that I have here? Is a bifilar, having the trigger coil in the coil with the drive, going to be better than having an external?
Ooh, that's a deep question.
And I've done them both. I think you get more speed from having the external coil. I do. I think you get more speed from that. I think you might get a little bit more energy generation from having a bifilar though, because there's transformer on transformer action going on in a bifilar coil that you can't deny.
So you got some trade-offs.
Yeah, there's some trade-offs, but right here it looks like we're generating at least enough to stay above water currently. 12.50. closed loop system. Sound like I'm selling
Yes, that's
it. I don't know. I'm definitely not selling this, but I think it's pretty cool. And I got two variations. One is this one right here, and the other one is an extension of this one, which incorporates this coil in the drive, which diminishes the amount of amps needed by a lot, like 200 milliamps.
welcome in, Jorge.
Hello. 200 milliamps less spending, but then at the same time, you know, you would think that with two coils you're getting two spikes, and what else would you be getting? Well, at least you're getting two spikes, right? Per coil.
Right.
One per coil. And it still spins faster with two coils than it does with one. I don't understand why. And to like get it running at a nice pace, you gotta put like 19 volts into it.
Thank you for the like.
Here, let's look at the bottom of our potentiometer. So I'm thinking that if that's 1,000, that's about 250 right there. 230, 250 ohms. And it looks like that's a good spot because our spending is way down. And I think we have a 230 ohm resistor just chilling right over there. So if I want to stop it and put it in there, I'm not going to do that. I'm going to leave the pot where it is because it's a permanent addition to the closed loop system. Whichever one I'm doing, the pot has to be a part of it. And but just for good measure, it's 230 ohms. Running it like this at 12.50. Can we get faster? I don't think so. Let me look at how fast it's going. I think 800 was my max. That's at 717 right now. So I think maybe we can go up to 300 ohms. Or we go down to 200 ohms. I'm going to leave it where it is. I'm just saying, if we wanted to like micro manipulate it, well, a viewer posted and said that as the speed goes up, you need to adjust to compensate for the speed going up. And I think that we can do that. I want to go the right way with this. So that we don't screw it up. So I think I'm going to go down with ohms, 200. But of course, the lower the ohms, the more you're going to spend. It's just how it is because it's incorporated into both the drive and the trigger. That's the way it's built. So both of them are going to be affected by the pot.
Thank you for the like.
Which is good. I mean, if it ends up with us being on top, then it's good, you know?
Mm-hmm.
Alright, So we're at 718, we were at 718 before the adjustment. So I don't know if it did anything. It didn't do anything.
It didn't do a thing.
Alright, so I'll look, just make sure we're at where we're at. Alright, so I twisted it up a little bit this time. We are at, I want to say 350. It is going down, so even less than the almost. Surprised we haven't lost any voltage with me and Josh in this thing so much. Awesome. Perfect. It's good. It's good practice. Get in here and get it right. So let's drop it to 100 ohms. See what happens. If we get to 800, I think we'll be good having it that low. I don't know. 714. 714. Now another thing that we can adjust is the trigger coil. We can move that around a little bit. Matter of fact, I'm going to pull it out just a little bit. Okay, that's the right direction. Yeah, alright. Good now. Good. So, little slight adjustment with the trigger coil, and we're on our way in the right direction.
On a roll.
720, 721. Alright.
Thank you for the like.
And we are still generating with this coil. It's just off, so it's not directly lensing wheel, which is good. We're getting the best of both worlds there. $729.
What's up, Mike Dawes?
Hey, Mike. Woo! $12.50. Still at $12.50.
YouTube switched it to everybody's handle, so the names are gone.
Okay, so it's M.P.H.
Yeah, if we were on someone else's, that's what yours would be. Yeah.
Okay. Sweet. That's good. I'm good with that. 731. So we're increasing in RPMs currently. Let me check my pot real quick, see where we are. We are literally probably at 100 ohms.
Thank you for the like. One more like, get us up to 10.
Maybe
Appreciate
80.
y'all.
Thank you. Thank you. We are up to, I think, 80 ohms. Down to 80 ohms.
10 likes. You guys are awesome. Yes. Appreciation.
80 ohms of resistance on the pot. 734.4. 734.4, 12.50 on the battery. So I'm thrilled that the last time I tried to do something like this, I think it blew up in my face or something like that.
Okay.
And I'm like, no, it can't be done, or some crazy stuff. This is good. And we are spending. This is not Unity or over here. It's close to Unity. It is close to Unity. Especially with this extra pickup coil here, we are really close. At 12.50. See, if it's going, and it's weird, because, the last, from 5.52 to 5.1 went really quick. From 5.1 to 5.0 went really quick. And now 5.0 has been here for however long, and I think it's because I didn't use the pot in the first two 100s. Man, math, when you're spitting math, it's like, it's hard for me to do sometimes.
100, Mike. 100. There will always be those who say it can't be done. Haters.
Oh, no. Yeah, well, I've heard it all. It can't be done, it can't be done. I'm doing it. And I don't think, I'm more of a believer now than I was before. Doing it myself, I've proven to myself that, 100th of a volt, you go a long way. $7.30. All right, so we got to adjust it again because we're starting to slow down. Is there anything to adjust? We're at 80 ohms. So I'm going to take it down 30.
30 ohms. We got 30 ohms on the potentiometer. Like and subscribe. Let us know if you have any questions.
And that might not be right. Oh, we're down to 12.49.
12.49. That's about a half an hour. You're right. 25, 35 minutes.
Okay, we are speeding up.
So we're, about 100th of a volt
We're back up to 1250.
every 35 minutes.
Yeah, something like that.
So that's a light spin, but we're spinning.
And as, of course, as it goes down, those numbers will change. Like every 100th of a volt that it goes down, it's going to spin slower. So you're going to generate less. And then you get sucked into that horrible vacuum that just ends up stalling your stuff out,
Mike's return the spike source.
It is. Absolutely, it is. It's the SSG return mode. It definitely is going back to source. Don't know how else to do it other than with the diode in reverse. So
Diode in reverse. Bum, bum, bum. Everybody needs some background singers, man.
724, 25, 1250. It is like at the bottom of 1250, going from 1250 to 49. It's like right here at the bottom of 1250, deciding whether or not it's going to go down or not.
It's flipping a coin. It's be like up or down,
It's
up or down.
It's flipping the two-faced coin.
Oh my God! So any dispute will be resolved by the flip of a coin of my choosing.
But I think the reason that it is happening so well, this might be what the problem is how I have the cap bank hooked into the system. Because I have the output of the SSG going into the cap bank, okay? And then I have the cap bank hooked to to the end of this cap bank. Okay? And then this cap bank is hooked to the battery. So that might be where my problem is. But as you can see, it's doing well. It's doing good, but that might be an issue. But I think as long as there's like a current where there's either like energy being pushed through or being sucked in, this should work. Now, it might not work.
You gotta suck it in.
Because the energy gets backed up at these caps. Because these caps are DC caps. So the energy can't flow through them the other way. They just flow through them the one way. Okay, so right there, the energy gets stopped here.
Right there.
So the only way it gets to flow is into the battery.
Right up in here.
At least I hope that's right. And that's how I incorporate the coil. Because there's only one clip for all the input going to be touching this battery. Okay?
Oh my good. One clip.
One clip for the input, one clip for the output. Or, the input of the SSG gets a clip. The output of all this other stuff gets one positive and one negative clip. Okay, so you got to find a way to combine it all together and shove it down that chute, or none of this is going to be. I couldn't do any of it because I don't have any of the other stuff, and I've told myself I'm not buying another thing. I'm only going to use what I have, and I can do some stuff with what I have, so I'm not even worried about it.
I'm not worried.
I'm not worried. So, but the pot is definitely helping.
Potentiometer.
Potentiometer. But, as of right now, I say the relay wins hands down.
Relay. Welcome in, everybody.
As to longevity.
No doubt.
Thusly. It's how, thusly. But we're still at 1250. And now that I'm done messing with the pot, I think we're going to have actually gained a little bit.
We gained.
Not a lot, because it's not even 100th, but a little bit. We gained a little bit because we're not at 49 anymore.
So like 5 1,000ths.
Yeah, if I had a meter that went to the thousandths, that would be freaking awesome. Then we could get some readings that make sense. Because all it is just staying here. There's no action. If there's no action, you're going to fall asleep.
All right, Yanni's asking for, I think the 2 diodes on the K energy circuit means running in gen mode, question mark?
Yeah, it is gen mode. So we're utilizing the negative spike. There's no switch. So we're not doing SSG mode. There's no switch on this. And its accompanying piece is right here. Okay, so there's SSG without gen mode.
So that would be single diode version.
Yep,
Okay.
single diode.
So he answered your second question before I even got to ask it. And then last question. Some differences, or can you gain a little with the single?
I haven't even tested a closed loop with the single one.
Okay.
This is just utilizing the negative spike with the gen mode. I know that the SSG runs a little faster, so that's definitely something we're gonna try. It is right here, so I am definitely thinking about trying that.
Gotta give it a shot.
I had the older SSG models with the switch in it because I bought 2 rounds of them, and I don't know. It's not that I was trying to switch it while it was on. I don't know what happened to it, but it fused, and then I tried to switch it while it was fused, and it snapped.
Ooh.
The switch snapped, and I was just thinking of ways I could bypass the switch at that point
Because it was snapped and fused.
and not connected.
That's
So-
horrible.
So I was talking to him about it, and he gave me an extra switch, but I don't.
That's a really nice dude.
Yeah, and then he made these 2 circuits for me without a switch. So I have one of each without a switch, and that's awesome too, for what I'm doing.
Rapid experimentation.
Rapid change, yeah. Entropy 1,000 degrees.
We'll get an AI to keep track of all this stuff you mentioned.
1250. There's 1250, ladies and gentlemen. But it did want to go down, but I think it's going up now. I think because of that slight increase in speed,
It's charging.
something. 724. It's not even that much faster. It might even be a little slower.
But there's a sweet spot.
Yeah, the sweet spot. The resistance.
The resistance.
So, what I ended up doing, right now all I have is the pot connected, but there's a space for you to put a resistor and a pot and fiddle with it like that. So you have your base resistance of 100 or more, and then you have your pot on the end of that to adjust, micro adjust. But it's to, I would say, protect your stuff for when you turn the pot just a little bit too far, and you're pulling 3.5 amps and you don't even know it.
Yeah, 3.5.
And you know, this is a tabletop toy. This is a table. This is the top of the table. Now, if you scale it to like an industrial thing, you're going to get different response. But, you know, for what it is, I think we get awesome readings. I think also this is a great closed loop system because we're still at 12.50. And we're like, we got to be at least 45 minutes in. So it stopped going down and it started going up as soon as I started messing with the pot. But you know that it going up, it's got a long way to go up to even hit 100. The way it's been, what do you call it? Equilibrium? Yeah, I don't know what it's called, but I mean,
Finding this equilibrium.
yeah, you got your input, you got your output, and right now we're kind of going like this. But eventually, if I like just leave it running, and it hits that next plateau and I don't adjust the clock, it's going to slow down. And it's going to fall down to the next plateau. But it's weird how it cascades back down. It's kind of like undertone.
Undertone.
And it's just bad news. But I think if I could get, I don't know, there's got to be more that I don't know yet about the clock. How to use it. 724. I think that's a good speed. 724. 750 might be better. Gizmo.
Mr. Gizzy.
Is that in?
No,
No?
not when it's on.
Okay. Smart. 49.
He'll be meowing.
49, ladies and gentlemen. 49. 5049. We're at the flux point now.
We are fluxing.
So I'm going to move this coil just a little bit closer. Not too much closer. Alright. We're not fluxing.
We have no flux.
50, ladies and gentlemen. 12.50 just from adjusting the coil a little bit. But how much slower are we going from that adjustment? 688, 686. So, yeah, the lens effect is definitely engaging here due to the load.
It's the load, y'all.
So if I disconnected the load, that coil wouldn't have, it's still lens, but it wouldn't have the load effect on it as well. 664.9, 665, okay. So maybe the flux in a different direction. $663.5. All right. So I'm going to reduce resistance just a little bit. Check the speed. 4.
653 RPM. Look at the concentration, folks.
So I'm going to back it up and add more resistance now. This is what I'm doing. I'm adding more resistance. Back up to 12.50.
1250
We're at
volts.
235, or no, 230 ohms.
230.
235 maybe. Let's see. $658.
Sorry.
Nine. So we're heading in the right direction with some resistance. Awesome. See that? We gotta play with it, man. We gotta get in there and move it around because as it increases, you gotta change it. But I think we're good for right now. Let me check. We might add a little bit more resistance.
He says it seems silent.
It is pretty much.
And there's a fan. We got a fan on right here, so you can barely hear past the fan. But what kind of sound? If depends on what's hooked up to it. It can sound like a freight train, like a tone, or silent like it is now.
Yeah, I'm saying that's pretty much from the external trigger coil. The internal one would be squeaking. It would squeak a lot, and that's the difference that I was discussing earlier. That with the bifilar coil, you get more interaction between the two wires than meets the eye. You know, there's a lot more going on there than just a trigger and a drive. Here they're separate. So it is quieter, definitely. But, I mean, when you have a single file coil like this one is, you can either run a trigger coil like I did, or you can use a Hall effect sensor like this right here. This is a Hall effect sensor. You can use that, or you can use a reed switch. You know, it's just when you do a bifilar coil, typically you would use each coil to do each action.
10 minutes.
10 minutes. Awesome.
Yeah, there is a certain pitcher pitching a certain ball, and I want to see how that went.
Okay.
This is the first time our team's gotten some love on Sunday night national in like 8 years.
So we're at 6, dropping like 600.
Do you have ceramics or normal bearings in here?
For steel bearings. And there's no maglet on this. It's just stacked up on bearing.
Propped up. Oh, is that bearing spinning or is that a reflection? That's a reflection. Okay. It does look like it's spinning though, doesn't it?
All right.
Thank you for the like.
All right, we're headed in the right direction. 618 and headed upwards.
Welcome in, Dadder.
All right, let's see what we're working with. About 350 ohms. And we're headed in the right direction. So I think we have about 100 ohms to play with in the reduction sequence. So when we get to the next plateau, we're going to reduce the ohms. 701. Yes.
701. It was like 630 last time. So you pumped up some ohmage. And higher ohms means what?
More resistance.
More resistance. Got it.
And it can go either way with the speed, depending on certain variances. But typically, reduction in resistance is going to give you more speed. Typically. It's not necessarily the case all the time. 647. Like right now.
647. Typicity. Just make up a word.
So we're going to... I don't know which way to roll it to reset it, so it's like...
Look at the focus.
So I'm just going to add a bunch, and then I'm going to start taking it off piece at a time. All right. $630.
630. It's 630 somewhere. Thank you for joining us tonight. We appreciate you guys.
Thank you. $641. 33. About 200 ohms.
200. 5 minutes.
All right, all right. I am, of course, going to leave this on.
So the rotor only got a hole through it? Yeah. And he 3D printed it, so he's got some good skill there. And sitting on a bearing. Yeah, it's sitting on a stack to get it to the right height because we are using spare parts to experiment right now.
Just the way everything came together, it doesn't seems like this is pretty much the best way to do it.
Yeah, you're doing good, man.
I mean, there's the rotor that's behind you. I want to like redo that one because you got to make room for the batteries in the rotor so that they don't fly away. 1249. Six, 657, 8. That's a steady upward trend. Don't know if I should mess with it or not. I think it's good. But there was that one like 300 ohms. It was at 700. One. And it was whipping right along. I was like, okay, this is the next plateau. And I turned it the wrong way or something.
Ooh.
You turned it the wrong way, people. But let's check it out. Six, 5, 6.
Yanni says you're doing great. Well done. Keep it going. Very cool.
Thank you. Appreciate you guys. Alright. So yeah, man. Great. So it took like basically the whole stream to get from 0.5, 11.5 to 0.49. That's an hour.
I'd say it's more than 35 minutes, yeah.
Okay.
Yeah.
That's pretty good.
Per 100th of a volt spend.
And that's running off of the same battery that, it's charging the same battery that it's running off.
In a closed loop system.
That's right.
Rock and roll, man. Thank you for the like. All right, closing remarks.
I'm gonna make a bifilar coil to run this with. It's gonna be about 1,500 turns at 20 and 30. And it's not gonna be anytime soon. It'll be whenever I can get it on, you know what I mean?
You can afford it?
Right. So it's gonna basically be one of these coils with a trigger string.
You don't have to be coy, man. You can be honest.
Yeah, I'm bored.
Mm-hmm. But not in knowledge, in joy, and experimentation, my friend.
All right.
You are not poor.
So I'm going to push this all the way in, and we're going to see how much it's going to generate before it turns itself, slows down.
Thank you for the like.
Nice. Nice. But it slows down significantly. Oh, there it's starting to do it right now. All right. Thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. Bye now.